All right, this is the new unit in geometry. It's unit 5, and it's called similarity. And this lesson is called ratios and proportions, and then similar polygons. Okay, so one definition to start, it's called a ratio. A ratio is a comparison of two quantities. The ratio of two numbers represented A and B can be written in several different ways. So one way to write a ratio is to write, if we're talking about A and B, you can say like A to B, like that. You could write an A and then a colon B. Or you can write it as a fraction, like A over B, as long as B is not 0. Okay, so those are your three ways you can write your ratios. Let's start off with an example you may see on the SATs. I've seen SAT problems like this. Okay, in a triangle, the ratio of the lengths of three sides is 4 to 6 to 9. Okay, and its perimeter is 190 inches. What is the length of the longest side of the triangle? Okay. So I'm going to start by doing this. I'm going to say the perimeter is when you add up all the sides. So I'm going to say 4x plus 6x plus 9x equals 190. That's the equation that I'm going to use to solve this problem. Okay, and now I'm going to solve it for x. So 4 plus 6 plus 9 is 19x equals 190, which means that x equals 10. So, I mean, the longest side is going to be the last one, so you can just do 9 times x. But let me go through each of them. For the first side, we have 4x. So that equals 4 times 10, which equals 40. My medium length side is 6x. So that equals 6 times 10, which equals 60. And my longest side is represented as 9x. So that equals 9 times 10, which equals 90. And you can see that when you add up these three, you do in fact get 190. But let's actually answer the question. What is the length of the longest side of the triangle? I'll say the longest side is 90 inches. Okay. Another definition. A proportion is an equation stating that two ratios are equal. Okay? So this is an example of a proportion. A over B equals C over D. And one way to solve this is to use what's called the cross products property, where you multiply the diagonals. If you have this, then you can solve it by saying A times D equals B times C. They multiply the diagonals together. Cross products property, it's called. Okay. Example 2. Solve each proportion for the indicated variable. So we'll start. I have 4 of these. We have 2 easy ones and 2 not so easy ones. Okay. So for example 2a, multiply the diagonals. 2 times x equals 5 times 10. So 2 times x equals 50. X equals 25. (2b), almost the same thing, but you have to be careful. You're going to do 2 times x plus 7, but you're going to have to distribute, okay? equals 4 times 10. Okay. So a lot of times people will forget to distribute. They'll do 2x plus 7 equals 40 in the next step. You have to make sure you distribute the 2. Okay, make sure you distribute the 2. 2x plus 14 equals 40. So 2x equals 26. X equals 13. All right, now we're going to do some tricky ones because these are going to involve quadratics. Multiply the diagonals. X times x minus 2 equals 3 times 8. So now you're going to distribute on the left. X squared minus 2x equals 24. Now there's several different ways to solve this if you think back to Algebra 1. Maybe factoring, maybe using square roots, maybe completing the square, maybe the quadratic formula. I'm going to get the equation equal to 0, and I'm going to try to factor. So I'll do x squared minus 2x minus 24 equals 0. And now I will factor the left side of the equation. Look for two numbers that multiply to negative 24 and add to negative 2. It's going to be x minus 6 times x plus 4. And now if you want to solve this equation, you're multiplying two factors to get 0. So one of the factors must be 0. Either x minus 6 equals 0 or x plus 4 equals 0. Solve each equation. X equals 6. X equals negative 4. Now, you have to be careful. You have to make sure that your answers work and that you don't get any denominators equal to 0. So this 6 does not make that denominator equal 0, so that's good. And this negative 4 does not make that denominator equal 0, so that's also good. Okay? But if you do want to check over your answer, if you do 6 minus 2 divided by 8, that gives you 4 divided by 8, which is a half. 3 over x, 3 over 6 also equals a half, so that one works. When you replace this x with negative 4, negative 4 minus 2 is negative 6 over 8 is negative 3/4. And the right also equals negative 3/4 when you replace the x with negative 4. Okay, so these answers both work, and they don't make any denominators equal 0. Okay, let's try example 2D. Multiply the diagonals. So 2x plus 1 times x minus 2 equals 3 times x plus 2. So on the left, you're going to have to multiply. You're going to have to distribute twice. Okay, distribute the 2x and then distribute the 1. All right, so 2x squared, this is a long problem. 2x times x is 2x squared. 2x times negative 2 is negative 4x plus x minus 2. It's going to equal, distribute over here, 3x plus 6. So now let me combine my terms on the left. 2x squared minus 3x minus 2 equals 3x plus 6. Subtract 3x and subtract 6. I want to get it equal to 0, so I'll bring the 3x over and I'll bring the 6 over. What I can do now to make it easy is I can factor out a common factor on the left. Common factor of 2. And now let me factor the parentheses. What two numbers multiply to -4 and add to -3? Pause the video if you have to think about that. It's going to be -4 and 1. So each of these factors equal to 0 and solve. You don't have to set the 2 equal to 0 because 2 cannot equal 0. But you're going to get x equals 4. And you're going to get x equals -1. You got to be careful though. Make sure none of your denominators equal 0 when you have this x at 4. Okay? 2 times 4 is 8, plus 1 is 9. So that's not 0. That's good. For this x equals -1, then you replace that -1 with, you replace that x with -1. You get 2 times -1 is -2. Plus 1 equals -1, so it does not equal 0. Make sure none of your denominators equal 0. Okay. One second. Okay. Example 3. A twin jet airplane has a length of 78 meters and a wingspan of 90 meters. A toy model is made in proportion to the real airplane. If the wingspan of the toy is 36 centimeters, find the length of the toy. Okay. So what I'm going to do for my proportion is I'll do length over wingspan. You have to be careful. There's more than one way to do some of these. If I do length over wingspan, the real airplane has a length of 78 meters, and its wingspan is 90. The toy has a wingspan of 36. I'm putting my wingspan to my denominator, and x is my length. So my numerators are my length, so I'll put the x up there, and that's the proportion I'm going to solve for x. So multiply the diagonals. 90x equals 78 times 36. 90x equals 2,808. Divided by 90, and you get x equals 31.2. So you can put that in a sentence. The length of the toy, or the length of the model, I guess, is 31.2 centimeters. The length of the model airplane is going to be 31.2 centimeters. Okay, so unit 4, the unit we just did was congruence. Okay, congruent figures have the same shape and the same size. All the corresponding angles were congruent, and all the corresponding sides were congruent. Now we're not going to do congruence because we just did that. The unit is called similarity. Okay, back to the first page, unit 5, similarity. Two figures that have the same shape, but not necessarily the same size, are called similar figures. And this is going to be the symbol for similar figures right there. Two polygons. What a polygon is a closed figure with no curves and no openings. Okay, so for example, squares, rectangles, triangles, trapezoids, pentagons, hexagons, octagons. Those are all polygons. Two polygons are similar if their corresponding angles are congruent, and their corresponding sides I'm not going to say they're not congruent, because if they're congruent, they would be congruent polygons. For similar polygons, the corresponding angles have to be congruent, but the corresponding sides have to be proportional. Meaning if one side is 5 times its corresponding side in a similar figure, every side has to be 5 times that side. The ratio of the lengths of the corresponding sides is called the similarity ratio. So we have 2 examples, or 1 example, 1 non-example. This is an example of similar triangles. Triangle 1 is similar to triangle 2. They're the same shape, but not necessarily the same size. And these are not similar. Not the same shape. This is the right triangle. This one is not a right triangle. Okay. Example 4. Given that triangle ABC is similar to, that means similar to, remember. Given that triangle, hold on a second, let's make a triangle. Triangle ABC is similar to triangle DEF, complete each statement. Angle A is congruent to angle D, because A is listed first and D is listed first. So this answer is angle D. Okay? Remember, the corresponding angles are congruent. The corresponding sides are not congruent. You can see clearly that AC is not the same as DF. So the corresponding sides are not congruent, but the corresponding angles are. Now remember, the corresponding sides are proportional. So what that means is, for part B, you can say that AB over its corresponding side DE equals AC over its corresponding side DF. So this answer is DF. Okay? In the next part C, you can say that AC over its corresponding side DF equals what over the corresponding side EF? EF corresponds to BC. So the answer will be BC. Okay. One second. All right. So like I said before, I believe this is a long lesson. It's 6 pages. And we're on page 4 still. Okay. We're going to talk about a scale factor. Now, we talked about scale factors when we did dilations. Okay. When finding the scale factor for 2 similar polygons, it will depend on the order of comparison. Okay. So let's pick two corresponding sides. So let's focus on AD and EH. Okay. AD corresponds to EH because AD is between the angle with 1 arc and 4 arcs, and EH is also between the angle with 1 arc and 4 arcs. Okay. So let's focus on this side and this side. Okay. If I say, what is the scale factor from this figure, ABCD, to this figure, the scale factor would be 2, okay? The scale factor of quadrilateral ABCD to quadrilateral EFGH is going to be 2. Okay, because the scale factor for similar polygons is basically like you're saying like this over that. So I would say like 6 over 3, which simplifies to 2. But if I say, what is the scale factor of EFGH to ABCD, I'm really doing this as my numerator over that as my denominator. So you see it's 3 over 6 now, which equals 1/2. I don't really care too much about these. I probably won't ask you for that on a test or quiz, I don't think. But just keep that in mind. Okay, the order matters. Okay. So let's try example 5. Determine whether the triangles are similar. If they are, write a similarity statement. I'm not going to worry about the similarity ratio for this. We can do it if you want. I'm just not. I don't want to focus on that. Let's just do the top line. I want to focus on the bottom part for now. Okay, so this is what I want to do. I want to do this problem right here. I don't want to worry about the similarity ratio. I just want to figure out, are the two triangles similar? And if they are, let's write a similarity statement. That's all I want to do for this one. Okay. So, are the two triangles similar? Well, we got to think back to the earlier page in this lesson. Sorry, I'm just trying to multitask right here really quick. Early in the lesson, I gave you what had to be true for similar figures. Okay, it was on page 3. Two polygons are similar if their corresponding angles are congruent and their corresponding sides are proportional. So we're really checking 6 things again. There are shortcuts like with congruence, but we're not learning those today. We'll learn those in the future. Okay. So here's what I'm going to say. I'm going to say, are the corresponding angles congruent? Let's focus on that first. Are the corresponding angles congruent? Well, angle L is congruent to angle P because they're each labeled with one arc. Angle M is congruent to angle N because they're right angles and all right angles are congruent. And I'm going to claim that angle J is congruent to angle S. Do you remember why? There's a theorem name. It's from Unit 4. It's called the third angle theorem. If you know 2 angles from one triangle are congruent to 2 angles from another triangle, then the third angles have to be congruent. So J is congruent to S. Third angle theorem. Now the question is, are the corresponding sides proportional? So let's see. What you're going to do is you're going to compare. Let's compare the 2 smaller sides together. Okay, you're going to compare this smaller side from this triangle with the smaller side from this triangle. So let's compare JM with SN, the 2 smaller sides. When you compare them, you get 45 being compared with 18. Simplify that fraction. Divide each one by 9, and you get 5/2. Now let's compare the 2 medium length sides from each triangle. In other words, let's compare ML, the 60, with NP, the 24. And let's simplify that fraction. So let's divide each one by 12, and you get 5 halves again. Okay, cool. Now let's compare the biggest sides of each triangle together. So let's compare JL, the biggest side 70, with the biggest side here, which is SP. So we're going to compare 75 with 30. Simplify that fraction. Divide each one by 15. You get 5 halves. So since each fraction simplifies to the same number, that means that the corresponding sides are proportional. Since they all come to 5 halves, then the corresponding sides are proportional. So yes, the two triangles are similar. So I'm going to say yes. Write a similarity statement. Yes, triangle JLM is similar to triangle. You have to go in the same order, okay? So just like with congruence, okay? J is listed first. J corresponds with S. So I have to put S first. Just like with the congruence. I have L listed second. L corresponds to P. I have M listed third, the right angle, that corresponds to N. Now there are shortcuts, but we have not learned those yet. We'll do that in the next lesson. Okay. Okay, we have 2 more examples. I know it's a long lesson today. The 2 polygons to the right are similar. Write a similarity statement. So you can either say polygon or you can say pentagon because there's 5 sides. I'll just stick with polygon in case you don't know the number of sides. That's fine for now. I'll say polygon RSTUV is similar to polygon. R has 1 arc, so it corresponds to A. S has 2 arcs, corresponds to B. And just make sure you go in the same order. Find X, Y, and UT. Okay. Now, there's a couple of tricky things about this. Okay. First of all, this should not be there. Okay, there's a couple of tricky things about this. Okay, number 1. There's more than one way to write a proportion, but not every proportion is written correctly. So you have to be careful. So I'll tell you how I do these. And then you can choose to do them the same way as me or not do them the same way as me. Okay? But I like to, when I write my proportions, I like to put all my numerators from one figure and all my denominators from the other figure. So to find X, well, first of all, I need to have the 18 and the 4 in my proportion because I know this 18 corresponds to that 4. So for my proportion, I'm going to do 18 over 4 equals X over 3. Now, this is the first key point I want to talk to you about. That is not the only right proportion. You could also do 18 over X equals 4 over 3, for example. But the way I do my proportions is I make all my numerators come from one figure, and I make all my denominators come from the other figure. So in this case, I made all my numerators come from the big figure, and I made all my denominators come from the small figure, okay? So I did 18 over 4, because 18 corresponds to the 4, equals X over 3. What you can't do is you can't do like 18 over 4 equals 3 over X. So I always make all my numerators come from one figure, and all my denominators come from the other figure. Cross multiply. 4x equals 54. X equals 13.5. Let's do y. 18 over 4. Again, I'm making all my numerators come from one figure, and all my denominators from the other figure. So y plus 2 over 5. I made both my numerators come from the big figure, and I made both my denominators come from the small figure. Solve that proportion. Cross multiply. 4 times y plus 2 equals 18 times 5. 4y plus 8 equals 90. 4y equals 82. So I'll do y equals 20.5. Find ut. I said find ut also. Ut equals y plus 2. So I'll say ut equals 22.5. If you want to throw on the meters, you can. Find the scale factor of polygon RS. Find the scale factor of the larger polygon to the smaller polygon. So the larger to the smaller one is going to be 18 over 4. Then you would simplify that to 9 over 2. Okay. 18 over 4 because they're corresponding, which simplifies to 9 over 2. If I said what's the scale factor of the smaller polygon to the larger polygon, then it would be 2 over 9. And then one more example. Get to in 1 second. Okay, one more word problem. It's kind of like the one we did earlier about the model airplane. Okay. The scale factor on the map is 2 centimeters equals 160 miles. The distance is 4.1 centimeters. Oh boy. How long would it take to drive across New Mexico if you're driving 60 miles per hour? Okay. So what I'll do is I'll write my proportion. I'm going to do centimeters over miles. Kind of like what we did in example 3. We did the length over the wingspan problem. I'm going to do centimeters over miles. So 2 centimeters is 60 miles. That's the map. Now it says the actual distance across New Mexico from east to west is actually 4.1 centimeters. So how many miles is that really? Solve this proportion. 2x equals 60 times 4.1. Cross multiply. 60 times 4.1 equals 246. Divided by 2. X equals 123. So what that means that should be 160. Oops. 160. Sorry about that. So it should be 160. Let me just change those numbers really quick. It's been a very long lesson, I'll tell you that. And on top of this, I just recorded 2 other videos, so it's been a long day. Let me just change this number right here. This number is the wrong number. This number is the wrong number. Let me fix that, and I'll be right back. Okay, so I accidentally put 60 the first time. It should be 160. Just make note of that. So when I do 160 times 4.1, I get 656. Divided by 2 equals 328. So that is how far apart New Mexico is from east to west. Now, the question is, how long will it take you to drive if you're driving 60 miles per hour? I'm going to use this formula. Distance equals rate times time. 328 is my distance. The rate is going to be 60 miles per hour times time. Divide that by 60. 328 over 60 equals t. I'll put the t on the left so it looks nicer. And let's write that as a mixed number. 4. It should actually be 5. Man, it's been a really long lesson. Let me just fix that really quick. I put 4 instead of 5. Okay, you're trying to simplify 328 over 60. So how many 60s are in 328? Answer is 5 60s. That gives you 300. So it means there's 28 left over. So it's going to be 5 and 28 60ths. Okay. So this number should be a 5. So what that means is it's going to take you 5 hours and 28 minutes. It will take you 5 hours and 28 minutes to drive across New Mexico. At 60 miles per hour. And that's the end of that lesson. That was a very long lesson, but that's what happens sometimes in honors class. So if you watch the entire video, then shout out to you. Okay.